Oh, that was cute. One goes up, one sits down, one goes up, one sits down. It's like the Bobbsey twins back there. Now, there's also another formula, and we're going to write it down. I think my battery's getting low on my jigger, on my and that is the mean of the standard deviation, the mean of the frequency distribution is equal to the summation of f times x over n. And that's the mean. So now you have the standard deviation and you have the mean. I'm sorry, I can't find the... The little doojiggers supposed to be down there. It's not. love it when they say, just hover over the thing, and you can't hover when it's not oriented. Hard to do this when you can't work in. Okay, people, I don't know what to do. I can't. This is so frustrating. I'm trying to find this calibrate, and somebody keeps taking it off the what you call it. So if y'all see calibrate, just let me know. Well, I done got out of it now, so. I'm about ready to quit. What that is. Okay, there's that. I don't know what that is. Just go away. Go away. Anybody sees it, let me know. Alright. I'm just going to do this. Alright. We need N. Can somebody tell me what N is? All the numbers added up. So add up all those numbers. And that's going to be your N. So you got N. Now you got to have F. Well, F is frequency. So you got your F. But what is X? Anybody know what X is? Anybody know what X is? X is the midpoint. I'm trying to write a text to the IT people. This has got me frustrated. What room are we in? Can't calibrate. Missing in 225. Help.
Okay. So, we're going to have to find out what the mid-range is. 10 plus 16 is what? 26. Half of 26 is what? 13. So, we need to organize this to where it'll be easy to do. So watch this. See this little box right here? That little box. Click on that. Copy table to clipboard. Take it over to your Excel spreadsheet. And look at there. Now, the reason I'm using the Excel spreadsheet right now, the only reason I'm using it is because it's a whole lot neater and more organized for me to put it on the board right here than me draw a bunch of squiggly lines and run out of room and stuff like that. I'm not telling you that you have to use Excel. Well, I know there's somebody in there out there going, oh my God, I don't want to do that. Okay? This is up to you. You can also use your handy dandy calculator if you can do it. There's a whole lot of steps in your calculator. The best way to do this is with the Excel spreadsheet. All right? Copy and paste it. Now this is not going to help you because you can't calculate these. These are classes. So what you need to do is break this up to the lower class limit and the upper class limit. So go ahead and do that. So what I want you to do is on your page, make some columns like so. Hold on. And this is, you can't do a spreadsheet unless you got your laptop, and if you want to, that's fine. Make some columns like this. The first one is going to be called lower class limit, upper class limit, and then frequency, and then the next one's going to be called X, which is your mid-range. So go ahead and draw those out. And that's why I'm using this, because I don't like doing that. I like doing it like this. So I'm going to go ahead and do the lowercase limit, the lower class limit, and the upper class limit. Lower class limit and upper class limit. And you're just going to put 10, 16, 17, 23, 24, 30, 31, 37, 38, 44, 45, 51, 52, 58. Okay, now some of you Excel geeks out there, because I'm an Excel geek, why did I do that? Because you can't calculate with two numbers in a cell. You can't add 10-16 to anything. 10-16 is a class. That might as well be a word. It's not a number. So I had to break it up into these two columns so I could calculate using the Excel spreadsheet. So that's up to you if you want to do that. You don't have to, but I'm going to calculate everything. And midpoint, X. What do we say the midpoint was? How do you do it? Equals parentheses 10 plus what? Plus 16 divided by 2. And then here's a trick I learned in the war. Just copy those down, and here's your numbers. Go ahead and check them. And I'll put that right here for you so you can see the formula right there. Excel is something that you need to learn how to use. Now let's look at our formula that we pulled up a while ago. And let's look at it and tell us what we need. What variables do we need? N, Hubert. That's right, class. We need N. Thank you for the interaction. What else? Do we have F? Yes, F is like the 2 and 3 and 8 and 1. We have that. We just found X, didn't we? What else do we not have? What other variable up there do we not have? Or term? X squared, Hubert. That's right, class. We don't have that X squared. So we're going to make another column. And what this column is going to be called? I'm going to open up my handy dandy spreadsheet, and I'm going to call this X squared, and that's equal to this guy raised to the second power, and then copy that down and check your numbers, see if you come out with those same numbers. Oh, we don't have N. N is equal to, hit that little summation button right there, and highlight your F column, and there's N. Now I want you to start plugging into the formula. Well, wait a minute. We haven't done F times X, and we haven't done F times X squared, so you need to do that now. So make another column called F times X, and make another column called F times X squared. I'm going to do them over here so we don't get them mixed up. F times X and F times X squared. I'm going to let y'all fill them out right quick. Use your calculator.
So, f times x equals f times x, and enter, and we will copy that down. And there's those numbers, and equals f times x squared, and copy those numbers down, and we need a summation here and a summation here. Now you have everything you need to find the mean and standard deviation. And I will go up here. Well, IT told me to reboot the computer. You know, can't do it, sorry. Bless you. God, this is like a nightmare. What did it say? Okay.
Well, lasted 3 classes. Things I do, you know. Now y'all should be able to plug it in. And some of y'all going, what? Plug in what? Where? What is he talking about?
Well, let's go back to our formula. There it is. There's the formula. I'm going to pull this up, and I'm going to make it smaller, and I'm going to pull it over a little bit right there, and try to do some plugging and chugging right here. What is my n? 97. 97 times the summation of f times x squared. Well, the summation of f times x squared is that big number right there. 219, 484. Alright, so we're going to multiply those two numbers together. But we're going to subtract the summation of f times x and square it. So there's the summation of f times x equals this. And, oops, I'm sorry. There. And then we're going to raise that to the second power. And all that's going to be under 97 times what? 97 minus 1.
let's crunch those numbers. Excuse me. Oh, I'm yawning. 97 times that number minus this number raised to the what? Second power? Huh?
I feel surprised.
97 times, oops, I'm sorry, equals 97 times 96. And now this guy minus this guy over this guy. And when we divide that out, we have what we call the what? Variance, Hubert. That's right, class. Okay, now the next step is very important for you to write in your notes. To find the standard deviation, you take the square root of the variance. Or raise it to the 0.5 power, whichever. So there are two very important pieces of information. Yes? Now what do we not have? There's only one other thing we don't have. The mean, Hubert. That's right, class, the mean. Y'all settle down, okay? Don't get too excited. Mean is equal to the summation of what? F times X, Hubert. Yep. Divided by what? N. And there is your mean.
I'm lost.
You're lost?
Yeah.
Well, I've achieved what I needed to do today. Y'all have a good day. All right. Well, let me pull this up just a little bit and let me take this out. And let me take this out. Let me take this out. All right, well, you got a question?
I don't know when you plug in the summations of the things, where are those numbers coming from?
Okay. I can't stop yawning. I'm sorry. When I want a summation, let me just erase these. Anytime I want a summation, you click on the cell and you click sigma right there. Click it one time and then highlight. Oh, well, it didn't do it. Hold on. Sigma. There we go. And then highlight those numbers.
Okay, but if we weren't doing it on Excel, is that number's just all those numbers added together? Okay.
That's what summation means. That's what sigma means.
Okay.
It means you add up whatever you just did inside that sigma. You're going to add them all up. That's what it
Okay,
means.
and so when you're plugging them into that formula, the first one is of the first, one would be which number if you plug into that one. Like that.
F times x squared. So you go to your column, find your column, F times x squared, and add it up.
Okay, and that's that number you plug in. Okay, that's where I was going.
And then F times x quantity squared, that's this number right here.
And
Yes.
then you would just have to square it after.
Mhm.
Okay.
All right, who else has got questions? Yes, ma'am. The mean is the summation of F times x over the summation of n, or summation of F, which is n. So that number right here divided by 97.
And you got the 97 from adding all the what together.
Yes.
Okay.
Now remember, what did I tell you frequency was? Head count. All right? If I ask you what is the head count in here, that's n. Here, you've got 2 blondes, 3 brunettes, 8 redheads, well, 2 redheads, 3 blondes, 8 brunettes, 1 purple hair, 10 bald people. Okay? You got different classes. But the people in here, if I want to know how many people are in the class, what I do? When you add them all up, you have n. N is always the class. Okay? All right, who else got a question? Now, the big question is, what the heck does all this mean? Well, I'm fixing to explain it to you. If y'all quit coughing and making noise, I might can explain it to you. Okay? This is really bothering me because I'm going to have to try to use this program, and I'm not really keen on using it because it's, I can, there it is. Okay. The 2 words that I use to talk about this section is called tight and slop. And there's nobody, not a teacher at this college, that's going to have any idea what I'm talking about. This is so frustrating. All right, I'm going to pull up a picture, and we're going to put some more definitions here. But the picture that I'm going to pull up all right, for those of you that don't know what a bearing is, well, let me. All right, this is a roller bearing right here. Everybody got a picture of that? That's a bearing. B-E-A-R-I-N-G. There's your rollers. Some they used to be a ball bearing. Some use ball bearing. Some use roller bearing. That's your outside race, inside race, and then your ball bearing. That goes into that, and it sits in there, packed with grease, and it just turns. That's all it does. It just
what in the heck? Well, just bear with me. All right? Where do you use bearings? Anywhere there's a shaft. There's a good picture of a shaft right there. I wish I could blow it up. No, that's not going to work. Well, there's your shaft right there. Now, this is a bearing right here. This is the bearing what? I know what that's called? Bearing housing. Houses the bearing. And then there's your shaft. See a lot of these in industry. Right? And what's that got to do with this? Well, what happens when a bearing goes out? Let's see if I can pull up a picture. Well, the bearing shaft's similar, that's good. We'll see if I can find a picture where somebody wallered out one. Give me a second. I'll find something. Did I not type out in damage? Bearing damage. Dommagé. Dommagé me le savoir. Okay, there we go. There's a shaft. There's a shaft right there with bearing damage. Right there. Look at it. See how scarred it is? There's a bearing that the roller has come out of. There's a bearing that's cracked because of the heat. Still not what I'm looking for. There's a bad bearing. What I'm trying to find is a term that some of you might not be aware of because it don't show up on any of your high school tests. Okay? It's called wallered out. I don't even know how to spell it. Anybody know what it means? There's one that's wallered out. And some of y'all are going, what in the heck is he talking about? Well, in just a second, I'm going to bring it all home. You're going to say, oh, I understand. All right, I'm going to show you a picture of a wallered out. That's what it means. I don't know. Somebody can look it up. But this picture right here, you see this right here? See that damage? See that? Wallered out is what happens when you have a shaft. Here's a hole, the bearing or whatever. Here's the bearing, and there's the housing, and the shaft goes through here like this, like that. And if the tolerance is not correct, then it's going to be beaten. The metal is going to be beaten up against the bearing, and it's going to keep hitting, and it's going to cause friction. And what's going to happen is this shaft is going to look like this. There's the shaft that's in here. And that bearing is going to eat up that metal,
And this thing, instead of a nice circle, it's gonna look like what? It's gonna look like that. That's wallered out. That's when something has been wallered out. It's been knocked out of shape. All right? Now, what causes this? Well, there's a word. When you're talking about metal, I don't know how to spell it, but I think that's it. Tolerance. What's tolerance when you're talking about a shaft and a bearing? Anybody know what that is? Anybody? Say again? Well, that's a different form of the word tolerance. And that's right, but the tolerance is what we're talking about is measurement. Let's say that this shaft is a 2-inch shaft. Okay? That means from here to here is 2 inches. Everybody with me? And it's got to go through a bearing housing. There's the bearing, and there's the bearing, and then another one. Like that. What's the opening right here got to be? A minimum of 2 inches, but it's exactly 2 inches. How are you going to get the rod in the bearing? You don't. So what does the bearing have to be in relation to 2 inches? Just a fraction above 2 inches. The shaft has to fit the bearing. You don't have to write this down, just think about it. The word is what? Tight. I want you to think of the word tight. Now, there is many definitions of the word tight, especially now. Okay? Tight means good. Most of the time, what definition you're using, it means good. All right? In statistics, what does it mean with data? It means it's valid. If you've got a lot of slop in your data, is that good or bad? Well, what happens when you have a lot of slop here? If this is a 2-inch shaft, and this is a 2.5-inch bearing, and you say, oh well, nobody's going to know it. I'm going to put that 2-inch shaft in that 2.5-inch bearing and run it at 50,000 RPM. What's going to happen? Those bearing housings are going to just disintegrate. And this shaft is going to probably break because it's metal against metal. It's just going to sit there and rattle and rattle and rattle and rattle until it does what? Something gives. Slop is no good. Tight is good. So, when you're talking about data, you want tight data. Tight data means a small standard deviation. Sloppy data means what? A large standard deviation compared to the mean. Let's say the mean is 68. You have a standard deviation of 50. Your data, just go back to the drawing board. Don't even show anybody that you have a standard deviation of 50 with a mean of 60 because they'll laugh you out of the room because your data is no good. But if you have a standard deviation, mean of 60 and a standard deviation of 2.2, then you have valid data. Make sense? And now you remember that tight, that's a good thing. Tight is a good thing. And small, slop, And a lot of people say, I can't believe people use the word slop. In a mechanical sense, if anybody's father or mother is in a mechanic or a mechanical engineer, anybody got a mechanical engineer or a mechanic father, mother, go home and say, what does the word slop mean in mechanics? And they're gonna say play. You ever drove a car, got in the car, and you turn the steering wheel and it don't turn? And you have to turn it like 3 inches to get it to start turning? That's called slop. Slop is in the steering wheel, the play. It's called play in the steering wheel. But it's basically slop in the gearbox. The gearbox that turns your steering wheel goes down into a gearbox. It turns a gear, and it turns another gear, and it turns your tires. If those gears are wore out, if they're not tight, then you have what? Slop. And what is your relative work on? Oh, he knows a lot about slop. Big hot word, Caterpillar? Okay. Yeah, you go to him and say, what does it mean when you got slop in a bearing or shaft in a bearing? What does slop mean? He'll tell you. It's metal against metal, and it's just rattling, and it's just shaking, and it's just fixing to blow all to pieces. So that's what you want. So let's go back to our problem. You go back to the problem at hand, and let's show you what we can do with this. Show you what we can do with these three numbers right here. I'm going to have to draw it on here, so just hold on. What time is it? Okay, that time. I want somebody to give me a definition of the word average without using adding up all the numbers and dividing by n. Okay? Can't use that. Tell me what the word average means. All y'all had probability of statistics. You had 12 years of math. You should be able to tell me what the definition of average is without saying add up all the numbers and divide by n. Must not be on one of the tests. Very easy definition. The average is the number that represents no variation. Average. Okay, I can't do this. Average is a number that represents no variation. Average is a number that represents no variation. And I'm going to show you what that means. I wish I could show you. I'm going to have to do it over here because I can't draw with this. So I'm going to draw a nice little graph up here. We're going to come back to this curve. We're going to come back to it. And I'm going to take my handy dandy straight line maker. And I'm going to draw a graph. And I'm going to draw, this is a graph, you know, like a bar graph.
Alright, so let's say we got some data here. This is equal to 20, this is equal to 30, this is equal to 15, this is equal to 20, this is equal to 5, this is equal to 18, okay? That's irrelevant, alright? The average, if I was to take this guy right here, and let's color him, I'm just going to use this rectangle maker because, let's see, where's the rectangle? I'll use this. I'm going to color it red. Well, that ain't going to work. All right, everybody with me? Take that right there, and I'm just going to move it. Right here. Okay, you got to use your imagination, and it's supposed to fit it perfectly, okay? Everybody with me? I cut that off, and when I cut it off, that made this piece go away, and I've got a straight piece right here, like that. And this goes away. And it's not going to go away because it's going to, no, it is good. All right, everybody with me so far? And then I take this piece and I color, let me get my handy dandy draw maker thing again. I'm going to color it blue. And I take that piece and I move it, and I move it right here. And this piece goes away. What have I just done to the variation of my data? I can't hear you. What?
Put it all together.
Is there any variation now? And that number that this line represents is the average. In other words, if you take your data and you cut it off here and you flip it over, and you cut it off here and flip it over and get it as level as possible, that is the number that's the average. I bet a lot of you didn't even know that. In other words, if you've got all right, now you can't cut all them tops off and invert them. But when you find that number, when you do add them all together and divide by 10 or whatever, you have found the number that if you cut all these pieces off and invert them and fit them all together, that's the number that has no what? Variation. And that is the definition of average. Now, once you find that, you have found the center. You have found the center of your data. And when you find the center of your data, then you can put your standard deviation with it. Let's go back to your notes right here. And that average is what? 46. I'm just going to say 46 because I don't feel like adding a bunch of decimals. So there's 46. And 2 standard deviations to the right. What's my standard deviation? 10. Thank God. We're going to say 10 because it's easy. What's 46 plus 10? What's 56 plus 10? 46 minus 10. 36 minus 10. And you've just found the 95th percentile of people between 26 and 66. And that's what mean and standard deviation is. Now, let me ask you a question. Is this standard deviation type? I mean, is this data type? Well, the median as well as the mean will tell you if it's type. Now, this is pretty tight because what's the mean is 46. If you get a standard deviation of anything above 20, like half, then you can get to that. But this, what? The 4, 10. So it's okay. All right.
what to look for, if you do something with data and you get like standard deviation, the mean is 60 and the standard deviation is 58, something's wrong. Okay? And that, my friends, is how you take standard deviation and the mean with a frequency distribution. Now, I will email